Hello, welcome to Calculus 2. My name is Dr. Waller. This is Taylor. We'll introduce Taylor a little bit more formally in just a minute there, but Taylor's passing out the syllabus for the class. Looks like most people are here. I have to count. We'll have to see. I'm going to talk a little bit about the syllabus, of course, and tell you a little bit about the class policies before we get to the lecture today. Let me see what I wanted to say first there. So the reason I'm mic'd up here is because I'm going to record the lecture, which really just consists of my voice and what's on the computer, right? So that will be recorded, and then I'll post those on the class Blackboard page sometime after class. So hopefully it'll be this evening, but it might be tomorrow before it actually gets posted, along with the class notes, because I'm because I want everything to be in the video. All the class notes will occur on the laptop. All right, so I'll be writing on the tablet, and so but that file I will also post on the class Blackboard page, which you are looking at the moment. And I'll mention in a second there what's going to be on that. Do we have any left over? All right, so I hope everyone got a copy of the syllabus there, right? Okay, so as I mentioned there, I'm Dr. Waller, and this, of course, is Calculus 2, right? Okay, so we have a long meeting time because it's for our class, so we're going from 1 to 2:45. We'll use all of that, but each day, but we might take a little break in the middle, right, to get a drink of water or whatever. So that we're not just sitting here for the full time. But so hopefully I'll remember to do that. I don't do that at a set time, so it depends on when I remember to do that. My office is in South 718, so not in this building, right over in the math department area, on the one main building. And there you can see my phone number and my email address, right? Email is the most convenient way to contact me, but you can email me through the homework system. So we are going to have online homework system for this class, and that's really a good way of emailing me, but you can email directly to this address. I would ask that you do not use the messaging system in Blackboard, okay? So avoid using the messaging system in Blackboard to contact me, because I don't get pinged when when I get a message in Blackboard. So it may languish there for days or weeks before I realize that someone has sent me a message in Blackboard, because we're not really going to refer to Blackboard all that much, okay, because we have the online homework system. So that will be our primary portal for the class. But some things will be posted in Blackboard, but it's not something we're going to be going to every day, okay? So, in particular, as I mentioned, the videos will be that we make will be posted here. The class notes will be posted here, and some other things, but it's not something that I'll be referring to in class every day, okay? So, so don't message me there, right? Okay, that's not the place to get in touch with me. So Calculus 2, just to give you a few words of what Calculus 2 is about. So it's kind of obvious from the title, right, okay, what Calculus 2 is about. In this class, we're going to, of course, extend and deepen our knowledge of calculus, right? So we're going to build upon the things that we learned in Calculus 1. Not to frighten you, but just to make you aware of the exciting challenges that are ahead for this semester. Calculus 2 is a class that has a notorious reputation for being difficult, right? So you probably have heard, Calculus 2 is hard, right? Okay, and so in many instances there are challenging things that you're going to learn in Calculus 2, okay? But hang in there and prepare for tests and go to tutoring and you can make a good grade in Calculus 2. But and of course, did I say come to class? That's really important. But if you don't do those things and you're sort of a little bit, you know, lackadaisical or not applying yourself in the class, then it is easy to bomb the class really quickly, right? So anyway, okay. So we are going to extend our knowledge of Calculus 1. The primary focus of the class is going to be on integration. So in Calculus 1, you're primarily concerned with differentiation. So you learn a lot of differentiation rules and how differentiation works and what applications of differentiation are in Calculus 1. But the second side of calculus, of course, the inverse operation to differentiation is integration. And you do learn about integration in Calculus 1, right? But you spend much less time on that than you do on differentiation. But integration is a much more challenging process than differentiation is. You can memorize rules for differentiation that will really allow you to differentiate any function, almost any function that you encounter, okay? But that's not the case with integration, all right? Integration problems are going to be challenging frequently, and there's not just rules that you can follow that will allow you to integrate a given expression, okay? Find the antiderivative of a given expression. So it's often a trial and error process, and it requires a lot of practice and experience, and so that's what makes this course maybe a little bit harder than Calculus 1, all right? Because our focus, again, is on integration. But it's not just going to be about integration. We will learn new functions, learn how to differentiate new types of functions in the class. We're going to learn about lots of applications of integration, so you can understand what integration is useful for. And then we'll also take up the issue, we'll also sort of generalize the idea of integration, which is related to, or which comes from the notion of infinite sums. So we're going to generalize that idea of infinite sums. An infinite sum is called a series, and so we're going to learn about a series outside of the context of integration and how they're useful, and how they work, right? Okay, in the class. That will be toward the end of the course. So it's not all just about integration, but a lot of it is. Okay, so a big chunk of the class is going to be about integration. We're going to start with that right today. Okay, learning some new things about integration. Okay, well, yeah. Okay. All right, so that's what the class is all about. We do have a book, but I don't usually carry a copy of the book. It's the same as your Calculus 1 text if you took Calculus 1 here. So it's by Larson. I think it's the 11th edition. But the reason I don't carry that around is because when you get access to WebAssign, which is the online homework system for the class, you will get an e-copy of the book. All right, so you get a full digital version. It's actually kind of nice, of the book embedded in the online homework system, and you will have to purchase access to the online homework system. So that is a requirement of the class, and you cannot get through the class without doing that, all right? So I know that's an additional expense, but that's the way college courses work, right? You have textbook expenses, and it's the same in this class as well. And you won't be able to avoid the textbook expense because you do need to have access to the online homework system, okay? That's where our homework assigned, that's where our grades are going to be kept, right? That's our primary online interface to the class, is that online homework system. So if you use that in Calculus 1, you'll be familiar with it. You will probably still have to purchase access, though, even though you had access last semester. It depends on if you last semester purchased a multi-semester access to WebAssign. You might still be able to use that, but for most of you, you probably didn't purchase multi-semester access, so you'll probably have to purchase that, okay? Now, however, you do not have to do that immediately because we have a 14-day grace period starting today, so I don't think you really would have to purchase access until 2 weeks from today. So what is 2 weeks from the day? The 27th, something like that, is when the grace period will end. Okay. However, you do have to enroll in the class still. Okay. And so even without purchasing access, and I'll show you in a second there how to get into the WebAssign. So again, if you've used WebAssign in your Calculus 1 or some other class, then you're going to be familiar with it. But it's easy to, it's a very intuitive system. It's easy to get to know how to use. It does have some, what's the word, eccentricities to it, okay, or some annoying facts to it that are going to come up from time to time through the class. But otherwise, it's pretty reliable and easy to use, all right? And the homework is a really important part of the class. So I'll mention that. That's in terms of the grading, it's going to be 15% of your grade. We will have 3 tests, which are 60% of the grade. So those are 20% each. So homework is almost as much as a regular test. And then we have the final exam, which is the final 25% of the grade. And then your letter grade is just assigned in the usual way, right? So 90 to 100 would be an A, 80 to 89 is a B, 70 to 79 is a C, and so forth, right? Okay. So hopefully everyone will be at 70 or above, okay? We do have here for this class a kind of elaborate extra credit system that I'll have to explain to you how that works, okay? So I'll say that in just a minute. But one important part of that extra credit system is going to be attendance. So I will be taking attendance starting either Wednesday or the following Wednesday. We're not here on Monday, so you'll get a little bit of a break for Martin Luther King Day. So either next time or on Wednesday, we'll start taking attendance. And so we do have an attendance policy, which is explained in the syllabus. It's a very simple policy to understand and to follow, okay? But there is an attendance policy, so we will be taking attendance. Even though I'm taping here, okay, and posting the videos, those are for your convenience. They're not really meant for you to rely on these videos and then not come to class. This is not an online class, all right? So you need to be here in person, right? It's not designed to be an online class. So the reason that I have the videos is that if you want to go back and review something from the lecture, I don't expect you to watch the whole video. But if there are pieces of the lecture that you want to review, the video is there, and you can fast forward to the part that you like. But also, if you do miss class, if you do have to miss class, and it is winter, so occasionally people will be ill or there will be weather issues, right? If you do have to miss class, then that's fine. Then you can watch the video, but you shouldn't be relying on the videos normally and not coming to class, okay? Because that'll put you in violation of the attendance policy. Sometimes So I just want to warn you off of this. Sometimes I get students who, who want to take advantage of the videos and treat the class like it's an online class, and then they do not come to class, and then they fail, and then they're really upset with me because they failed, and then I have to go back and point out to them, but you were absent half of the class periods, right? What do you want me to say here, right? Okay. You were absent half the class periods. That's why you failed, right? So, don't fall into that. Don't fall into that trap. Okay. So we're not here till 1 o'clock. So most people can make it here by 1, right? Okay. I don't think that's going to be a huge issue. All right. So let me introduce now Taylor. So we have a really special resource for the class. We have a supplemental instructor, okay, and so that is really a luxury for this class, and so it's something that you want to take advantage of because, as I mentioned, Calculus 2 has a notorious reputation, and so you want to take advantage of what help you have here in the class, and one of those things is Taylor. So Taylor, do you want to introduce yourself?
Hi, I'm Taylor. I will be the Substitution is a program here at UHG that targets historically difficult courses. It's a little bit different than regular tutoring. I have 2 sessions twice a week, which will be held on Mondays and Wednesdays from 11 to 12, so right before class. And they're more activity-based as opposed to just regular tutoring where you come in and ask questions. I'll use the previous lecture to kind of create like a game or something like that. We try to encourage teamwork and collaboration. The goal is to have you all doing as much as possible and me doing as little as possible. So I'll also be holding exam reviews before the exams, which will usually be on like the class before the exam. Even though it's right before, I like to do it a couple days in advance so we're not cramming. So that's about it. I'm going to pass out a flyer that has my times on it, and on the back there's a little cheat sheet, which I just realized kind of needs to be updated, but it'll be a little bit useful.
Okay, so we have an SI for this class, which is kind of like our private peer tutor, right, for the class. So I really strongly encourage you to, if you are free from 11 to 12, to go to Taylor sessions, okay? Either every session or once a week, go to Taylor sessions, because those students are students that do well in the class, right? Okay, so really take advantage of that opportunity, all right? And don't wait until after the first test and until you've boo-booed on the first test, right? Go ahead and start with Taylor early, so you don't get one bad test score. Okay, now we also have the Math Center though. So the Math Center also works well for tutoring, although that's just walk-in tutoring where you ask questions of the tutor. So Taylor sessions are a little bit more structured. She's going to have activities planned for you, but in the Math Center, which is in North 925, you just have to go there and ask questions of the tutor, okay? So you have to raise your hand and ask the tutor questions, but the tutoring there also is excellent. So there's another a resource to take advantage of, North 925, right, the Math Center, okay? And so the hours there are in the syllabus. Now, that brings me to our little bit of our extra credit system, which is, our extra credit system, which is called Calculus Flux, right? Now, I should call it something different. I forgot what the other term was, because now we're dealing with fluence. I should call it Calculus Fluence, but because fluence was Newton's term for integration. Fluxions was Newton's term for differentiation. Well, okay, so we are going to learn a little bit of differentiation, though. So the way Calculus Flux works is that you earn flux dollars through the semester for doing various things, okay? And there is a list there at the back of the syllabus which explains how you earn flux dollars. And one way you can earn flux dollars is by attending tutoring, either Taylor sessions or in the Math Center, okay? And you can get $2 per week, not per session, but $2 per week of flux dollars if you go to tutoring, okay? And I keep track of this. I keep it in the WebAssign gradebook, so you know what your flux total is through the semester, okay? And you start building up flux dollars, and then at the end of the semester, you can purchase extra credit, right, in various ways by spending your flux dollars, all right? So how do you earn flux dollars? Well, attend tutoring is one way. Maintaining scores on your midterm tests will also earn you flux dollars. Keeping up with your homework will also earn you flux dollars, as you can see on the list there. And sometimes I have a bonus homeworks where you can earn flux dollars, okay, extra credit homeworks. And then, but another big way of earning flux dollars is through the attendance policy. So if you are not absent more than 4 times during the semester, then you can earn 25 flux dollars, all right, automatically, okay, for the end of the semester. And then, like I said, you can use those flux dollars to purchase extra credit options at the end of the semester. So one thing you can do with your flux dollars is, if you have 25 flux dollars, is you can use the final exam to replace your lowest midterm score, okay? That only costs you 25. Or if you're fortunate enough and have a lot of flux dollars, you can completely buy out of the final exam, okay? So that it is possible to get out of the final exam entirely through Flex Dollars, okay? You can also buy midterm points on your tests, your midterm tests, through, okay? So there are a variety of ways, as you can see, there are earning Flex Dollars and a variety of ways of spending those at the end of the semester. Now, here's the way Flex Dollars, here's the way my experience with Flex Dollars is with students. Some students are very goal-oriented, okay? And those tend to be really good students anyway, okay? So they, because they're thinking from the very beginning of the semester, what do I have to do to make a good grade in this class? And then they are throughout the semester doing those things, okay? And so they often earn a lot of Flex Dollars and are often able to buy out of the final exam. Some students are a little bit less goal-oriented, okay? So they're not really thinking about the end of the semester at the beginning of the semester. They may be thinking about what they're going to have for dinner tonight, right? Okay, but they're not really projecting very far ahead, okay? Or they might be looking to what am I doing next week, right? Okay, and those students don't usually earn a lot of Flex Dollars, and then but until about halfway through the semester, they realize, ooh, I could use some Flex Dollars, okay, because that may help me. Or sometimes even later in the semester, they'll realize when it sort of comes into their time horizon. And then they'll start thinking about earning Flex Dollars. So what you want to do is, what I encourage you to do is go ahead and think about earning Flex Dollars toward the end of the semester now, okay? So don't let this, don't start thinking about this 2 weeks before the end of the semester. And so you can earn Flex Dollars by going to tutoring to start with, okay? And making sure that you're keeping up with your homework to start with, right? Someone had a question.
Oh, I have a question.
Okay.
For the homework, is it per homework or per section?
No, it's the total homework average at the end of the semester, right? Okay, yeah. So if you can keep that above, what did I put there? 82? Yeah, you earn 10, or if you're above 87, you can earn 15. Okay, that's usually easy dollars to earn because this is an online homework system, so you have chances to correct your work, right? And of course, you can ask questions in Taylor or in the Math Center when you have a problem on your homework that's tough, right? So so it is possible to keep your average up if you're consistent about doing your homework, right? Okay, and applying yourself to that. Yeah.
For the $25 option,
Mm-hmm.
is it only a one-time purchase? Or?
Yeah, it's just a one-time purchase, right? Yeah, at the end of the semester, say you had a bad grade on the first test, you had a 50, but that was just because you didn't know what to expect on the first test, right? So and then so then what you can do is with the $25, you can have the final exam replace that low test score, right? Okay, yeah.
Do you know how many tries WebAssign is going to give us?
Well, yeah, okay, that's a good question. So, all right, so it's 5 for each question. So there is a limit, but I think in the later homeworks I had reset that to 7. So sometimes it's 5 and sometimes it's going to be 7. Well, okay, when you're doing a homework in a problem in WebAssign, you often won't get it right the first time, and so it will allow you to try again, right? It doesn't change the problem; it just allows you to answer it again. And I think you get 5 tries. But once you have exhausted now WebAssign is not so friendly as some other online homework systems. So once you've exhausted the 5 tries, it gives a similar problem. It's just you have missed that problem, and there's no way to recover. So so what you need to do is if you're running out of tries and you're aware of it, you need to get help, okay? So either ask Taylor or ask me in class, or go to the Math Center and ask someone, or you can email me. So there's an option there for Ask Your Instructor, and so it will email me a copy of the problem, and I can sometimes, depends on how complex the problem is, sometimes I can answer your question online, but sometimes I'll have to bring it back to the class. Frequently, questions in WebAssign relate to the format of the answer. So you may not be typing the answer how WebAssign wants it typed, and if you email me that, I can usually tell you, oh no, you need to change the expression. Or sometimes it's sometimes very exacting about decimal places. It wants like 5 decimal places, and so that's really annoying sometimes. But if you think you've got it right, but it's not grading you correct because you suspect it's decimal places, you can email me and I can say, here's what the right answer is. You're off in the 4th decimal place or something. Yeah.
For the Flux points,
Mm-hmm.
when it says less than
Yeah, you can lose flux dollars. Yeah. Yeah, that is possible to lose flux dollars, right? So I don't want you blowing off tests. So if you make low scores on tests, you will get subtracted from your flux dollars. Okay? Yeah. Yeah.
So if you can't attend those sessions right there because you have a class during that time, but you go to the
Math Center, yeah, you still get the $2, right?
how would you keep track of that?
I am sent a report. Yeah. Okay. So I will know that.
And how about the CLCC?
I do not get a report from the CLCC. Okay, so I cannot reward you for that. I mean, I would certainly encourage you to go, but you won't earn flux dollars that way because they don't give me I can ask if that's possible, but normally I don't. I just get it from the Math Center and from supplemental instruction. Yeah.
How many bonus points can we put on the midterm?
You don't need to. You can put as many as you can afford. But you don't need to choose a particular midterm because all the midterms have the same weight. You can just say, I want to buy midterm points. And it doesn't matter if it's 1, 2, or 3. Okay, it'll come out the same. Yeah. So, but if you had, 90 flux dollars and you wanted to buy 30 midterm points, that's what you could afford. You can do that. Okay. It's up to you. Yeah. Okay. Does that kind of answer those questions? Someone else, yeah. Yeah, let me log on to WebAssign and I'll show you that. One other thing I was going to say. Oh yeah, so the schedule there, the rough schedule there is on the back. So it may be that the sections that we cover don't quite match up with what I've got listed there because the timing of the class varies from semester to semester. But I will try to stick with the test dates. So wherever a midterm test date is listed, I will honor that. But we may not be covering exactly the sections that are shown there as being that midterm test. The final exam I have there is TBA, but I do know the final exam. It's going to be March the 6th. No, May the 6th. I'm sorry, not March the 6th. May the 6th. All right. So, and it's a regular time here, but it's May the 6th. That's a Wednesday. So that's when our final is. I'll update that on the syllabus that's on the web page. Haven't done that yet, but so if you lose your syllabus, you can always find the syllabus on the web page. Okay. Also, what will be on the web page, as I mentioned, are the class notes and videos, and then the sample test. Well, we have sample tests for every test, and so a very comprehensive sample test for every test. So those will get posted here, and then the answers will be posted here before the test, and then, of course, the test answers will be posted here. So those are primarily the things that will be in the Blackboard page, okay, mostly. Your grades are not kept on the Blackboard page. They will be kept in WebAssign, okay? And, of course, your homework is in WebAssign. So really those are the main things that are going to be in Blackboard. It's just easier for me to post documents in Blackboard than in WebAssign. Okay, so that's why we don't use WebAssign exclusively. The only other thing from the syllabus is about classroom policies. So I don't have a lot of classroom policies. As I mentioned, we do have an attendance, right? Okay, and I do have a little bit of a bias against cell phones. So I'd like not to have cell phones out, okay, unless we're going to be using cell phones for some reason. Sometimes they're useful in the class because we will use technology from time to time, which you will be able to access on your cell phone. But in general, I don't want to see cell phones out, okay? So keep your cell phones away, right? Try to stay engaged with the lecture. I know since it's a long class, that can be challenging, but try to stay engaged with the lecture. That'll really benefit you in the long run. Let's switch to the WebAssign since someone asked about that. So the address there is webassign.net. It's .net. So when you first go to webassign.net, this is the page you're going to see, right? So you need to first enter the class key. All right, so that is to get you enrolled in my section. So if we click on this, let's see what happens. It's going to ask you for a class key, right? And that is in the syllabus. Can y'all read that off? I don't have that memorized. So you only need this once. So what is it? UHD, whoops. UHD, and then what? 9636, and then 0119. Okay, so let's try enrolling. And yeah, see, that's the right class, right? So you can say, yes, this is my class. And then at this point, you are going to have to create a username and a password, right? So if you already have a username and a password for WebAssign, so if you've used WebAssign before, you can still use that same login information if you remember it, okay, right? Otherwise, you will have to create an account, right? So that will consist of an email address, which will be your username, and then whatever password you pick, of course. The email address that you use here, try to pick an email address that you actually look at, all right? So if it's GatorMail, that's great. You can use GatorMail, but you're not required to use your GatorMail there. Pick something that you actually will get the emails for, right? So whatever email is linked to your smartphone might be a useful choice there, okay? But if you want to use GatorMail, then that's great too, all right? So that's your choice. But I'm going to be emailing you from time to time, right, through WebAssign, not through Blackboard, but through WebAssign. And so I want you to at least get the messages. So so pick an email that you're actually using there, right? Okay, for me. All right, so I'm not going to go any further with this, but you can follow the steps, the remaining steps there, and you will get enrolled in the class. You do not have to purchase access immediately. You have a 14-day grace period where you can work on the homework as you wish, and even when you go past the grace period, if you have not purchased the access yet, it will just block you from doing any extra work, but it's not going to erase things that you've already done, okay? All right, so so don't worry about losing work that you've already done if you're not able to purchase the access in the first couple of weeks. But you do want to get it as soon as possible, right, after that grace period is over, so that you don't in any way get behind. Let me go back here now and see if I can just log in as me. All right, so of course the page I'm going to see is a little bit different from what you're going to look at, but let me open the student view. And so we already have, so this is what you'll see when you log in. And so we already have a couple of assignments posted, okay? So, and now I'll have to see if those due dates are realistic, but I put due dates on them anyway. So for the first homework assignment, which we're going to talk about here momentarily, that for the currently is due next Wednesday. Now we'll see if we can pull that off. All right, and then this now homework assignment is actually not due until the first test. So you can be working on this. We'll have other homework assignments before the first test. But I want to go ahead and post this because you can start working on this, but it's not actually due until the time of the first test, which is scheduled, I think, if I got it right, for February 19th, right? So, so this will be a homework assignment counting toward your grade. So, but you can work on it slowly. There's only 17 problems on it, and it's just a review of questions from Calculus 1, right? Because I want you to brush up a little bit on your Calculus 1 skills. We'll review Calculus 1 skills as we need them, right, for this class, but of course I'm going to assume that you have a fairly decent working knowledge of Calculus 1, right? So we're not going to be able to go back and do a formal lengthy review of Calculus 1. But this homework will help you with reminding you, right, of some of the important skills from Calculus 1, right? Okay, that you need to be sort of fluid with, right, or fluent with in this class. Okay, so already got 2 homework assignments, and this is often where I make announcements for the class. Here is over on this right-hand side, right? So here are just kind of, some basic announcements, right? Where my office is, what my office hours are, email address, and so forth, correct? Okay, so those are standard announcements that will be there through the semester. Someone asked about due dates, okay? So homeworks do have due dates, right? And so there, I know different instructors have different methods of handling due dates, but I have due dates that are, come and go on a regular basis. So you need to be aware of those due dates. However, if you miss a due date, so if you're not finished with an assignment by the time the due date rolls around, you can continue working on the assignment, but you will have to request an extension. However, you get it automatically, okay, right? So if you request the extension within 2 days of the due date, the original due date, you'll get an automatic extension. I don't have to approve it. You just get that automatically. And then you have a couple of extra days to work on the assignment. Now, of course, you can earn additional points on the assignment, right? But there is a penalty for the new points that you earn, not the points that you earned before the due date. But for the new points, you will lose 40% of those. You only get 60% of the new points, okay? So if you had an 80 before the due date, and then you went back and finished it and got the 20 additional points after the due date, you only get 60% of those, which is 12. So you'd end up with a 92, okay? You couldn't end up with 100, all right? But that does give you a little bit of a chance to run past the original due date, okay? So our first due date currently is January 22nd. We'll see if we have to adjust that or not, okay? So I frequently adjust due dates. So usually when you come in every day, I'll be showing the WebAssign so that you can sort of keep up with, what our current assignments are and what the due dates are, right? Okay. All right. So easy to get into WebAssign, and I don't think we're going to actually work a problem right now. So, but we might next time. So you can get a feel for what how you enter answers in WebAssign. But that's pretty straightforward. Yeah.
You have on your syllabus that we can bring a 4x6 index card.
Oh yeah, I forgot about that. So we'll talk more about that. But on the test, you can bring an index card, right? Okay, any standard size index card. So the most standard of the standard size index cards, I think, is 4x6. But there are 3x5 and 5x7 index cards. Those are all standard sizes. You can bring any one of those. So you can bring that to the test. Yeah. Okay.
What are we allowed to write on it?
Yeah, anything. Okay. So yeah. So anything at all that you can fit on there, you can bring. And so that I call that the survival card. So you can use a survival card, right? Calculus 2 is going to have lots of formulas. And so, and they're complex formulas. They're not simple formulas, so they're not easy to memorize. So, or at least memorize all of them. Some of them you'll memorize because you'll use them a lot, but you usually can't memorize every single one of them. So, the index card's really helpful. Yeah.
Those sample tests that you said was going to be on Blackboard, those are basically like sample midterms.
Yeah, they're like sample midterms, right? Yeah. Okay. So. Before we take a test, the best practice would be, from your point of view, would be to do that sample test completely prior to coming to take the exam, okay? Because that will give you a really good practice for the exam, yeah, okay? And now, it's only a sample, so it's not a duplicate of the test, but if you can do the sample test, then usually you will score okay. Maybe not 100, right? But you'll score okay on the test. And Taylor will use those and other things for our test reviews when she's doing test reviews. Okay, yeah. Yeah, well, that's 1, right? Yeah, 1, right? Okay, and it has to be a standard size, so it can't be, a poster size index card, right? Okay, it's got to be a standard size index card. Yeah, so one that you have, one that you can purchase, right? Okay. All right. All right. So those are all good questions. I probably forgot. Did I forget to say something? How could I have forgotten after all that time, right? All right. So. All right, so those are good questions. I think we covered kind of the real basic policies for the class. So I encourage you to get onto WebAssign quickly, because you've got the grace period. So go ahead and enroll in the class immediately, even if you don't do anything after you've enrolled. Go ahead and enroll so that you won't make me nervous about the number who have enrolled. Some people have already enrolled though. So some people are reading the syllabus and I guess and have already enrolled. So I've got a few people already. Okay, so go ahead and get that done before next time. Even if you don't start the homework, do that so we can have everyone on the roll. And if I'm sending out emails, everyone will get the email. Okay. Now Taylor though will probably email you through Blackboard, right? Okay, so Taylor may contact you through Blackboard, but I will not typically email you through Blackboard. All right. Okay, so before we take our break, though, we've got to start, okay? So if there aren't any other questions, we're going to start with our notes today. So this will, for a few minutes here, this will be familiar, and then we're going to veer off into something that's different. Okay, all right. All right. So let's recall from Calculus 1 what I call the Antipower rule. But your instructor from Calculus 1 probably did not call it the Antipower rule, okay? But that's the terminology that I use. But it's a very familiar rule for integration or anti-differentiation, right? Those are those terms are synonyms, right? From Calculus 1. In fact, this is the just the sort of the standard integration rule that you learned first in a Calculus 1 class when you're first learning how to integrate, okay? So here is the so-called anti-power rule. So it says if you're looking for an antiderivative, right, of an expression that looks like this, where you have just your base x raised to a power, right, so you have a power here, okay, then that's easy to find the antiderivative, okay, according to this formula. It says, so you're very familiar with this process, right? It says, add 1 to the exponent, correct? Add 1 to the exponent, and then divide by the new exponent. Of course, you have to add on an arbitrary constant here, right? Because this is a general antiderivative, right? And that will give you the antiderivative, right? Okay, so that's it, right? Now, however, there's one little sneaky exception that you really have to pay attention to with this rule. So this is really going to be the real major starting point for this course. Notice that the exponent here cannot be -1, right? Okay, so that's real important to the rule for pretty obvious reasons, okay? But the exponent can be any other real number. It does not have to be a whole number, right? The exponent does not have to be a whole number. So it could be a 1/2 or a 1/3 or a 3/2 or a -1/2, all right? Or a -2, okay? Does not have to be a whole number. It can be any real number except it cannot be -1, all right? So there's that exception. All right, now look, how do we know that the antipower rule is correct, all right? So how can we verify that the antipower rule really is, really does work, right? And here you have to recall, of course, what integration really means, right? So see, when you're finding the antiderivative of this expression, x to the nth power, right, we're finding the antiderivative, then what that means is you're finding the expression or you're finding the function whose derivative is x to the n, right? Okay, so we're looking for the formula whose derivative will be x to the n. That is the antiderivative of x to the n, okay, right? So to verify that this formula is correct, all we have to do is take the derivative of our antiderivative, right? Okay, to check this, right? Just take the derivative of x to the n plus 1 over n plus 1 plus this constant, okay? And what do we want that to turn out to be? Well, we need it to turn out to be the integrand here, right? So we want this to be x to the nth power. If this turns out to be true, then we know this formula is correct, right? Well, let's see if we can do that there. So how do we take, and we're usually much better at taking derivatives than antiderivatives, right? So how do we find the derivative of x to the n plus 1 over n plus 1? So what's the rule for taking this derivative? What do we do? That's right, yeah, right. You bring the power to the front. Y'all remember that now? Right? So you bring the power here, the exponent down in front, right? Okay, and then what do you do with the exponent? You subtract 1 from it, correct? Right? Is that all ringing? That's not ringing a bell? Or y'all just holding out on me here? Okay? No? Let's raise hands there. How many recognized how that worked? Okay. Oh, all right. So see, y'all do know here, right? Y'all are just playing dumb. All right. So what you do there to take the derivative, this is the notation for, or one notation for derivative, right? Okay, is what y'all just said, right? Bring the exponent down, so you have n plus 1 times x to the n plus 1 minus 1, right? Subtract 1 there, correct? Don't forget now, this n plus 1, though, was part of the antiderivative, right? So that's still there. We also have to take the derivative of this constant, but what's the derivative of the constant? 0, right, okay? This is just a constant. It doesn't have the variable x in it, right? So its derivative is going to be 0. And, of course, this simplifies very nicely, right? The n plus 1 factors divide out, correct? And so you get x to the n plus 1 minus 1, but that's just x to the n. And, of course, you're just adding on 0 there, right? So see, that is correct. When you take the derivative of the antiderivative, when you take the derivative of the antiderivative, you get the original integrand, right? You get the expression that we were trying to integrate. So that's very quickly we can verify that this anti-power rule is correct, right? So that's a very useful rule because we are often trying to integrate expressions that are powers, okay? That's a very frequent type of expression in algebra, right? A power. And so we're frequently trying to integrate those, okay, just because they occur frequently. And so the anti-power rule is very useful in telling us how we integrate, right? Okay? Except for this one exception, okay, right? That's really ugly. The power cannot be minus 1. Why can the power not be minus 1? Why does this formula not work when n is minus 1? Yeah, you get 0 where? Yeah, you get it here in the exponent. That's not such a big deal. But what's really bad is you get it in this denominator, right? So you're trying to divide by 0, okay? And that's not a defined operation, right? You cannot divide by 0. So the anti-power rule is going to work nicely, but it's not going to work when this power is minus 1, okay? That is the limitation on the anti-power rule. All right, so do you see why I call this the anti-power rule? Because this differentiation rule that we used right here to differentiate this expression, that is always called the power rule, okay, right, okay? The power rule is right where you take the exponent down, right, subtract 1 from the exponent, okay? That rule for differentiation is called the power rule. Well, see, what I'm doing is I'm using that power rule kind of in reverse, right, to find an antiderivative. So that's why this antiderivative rule is called the anti-power rule, because it's the opposite of the power rule for differentiation, okay? All right, let's take an example of that. All right, so this is just a general rule. Let's actually apply that to a specific antiderivative, right? So let's see if we can find this indefinite integral, this general antiderivative, not a definite integral because we don't have limits of integration here, right? But this indefinite integral for 3x squared, okay? And so we look here and we say, wow, that's almost the same as this antipower rule, correct? Because here I have x raised to a power. Very simple power here, 2, right? Okay? So I should maybe be able to apply this antipower rule. But now, one thing is getting in the way. In the antipower rule, what's this coefficient here? 1. But unfortunately, in this problem, it's 3, okay? So this does not quite fit into the format of the antipower rule. But that's easy to fix, all right, okay? Because you can factor constants outside of integrals, all right? So that's one of the nice things about integrals is constants, not variables, but constants can be factored outside of integrals, all right? So that 3 can be actually moved in front of the integral sign. So you can rewrite this as 3 and then x squared dx. And now this part, not the 3 of course, all right, but this part perfectly fits the antipower rule. So we can find this antiderivative using the antipower rule, right? And then of course we'll have to remember that we have this factor of 3 here that's got to be multiplied in, right? So, but that's just going to go along for the ride. Okay, we're going to ignore it from this point on. All right, so according to the antipower rule, right, what is the antiderivative of x squared? That would be what? What now? X cubed, right? Add 1 and then divide by what? 3, right? Okay. And then don't forget to add your constant. Well, here, this is nice. The 3's divide out, right? So we get, as our antiderivative, x cubed plus a constant, right? So we can make short work of this integrand, right? Of this antiderivative, just by using the antipower rule. Now, look, if we take the antipower rule and then we combine that with the chain rule for differentiation. Ooh, there's an ominous phrase from Calculus 1, the chain rule. Remember, the chain rule is one of the rules we use for differentiation, right? Do y'all remember that? Yeah, chain rule. Remember that phrase, right? Okay, yeah. So if we take the antipower rule and combine that with the chain rule for differentiation, we get a more powerful version of the antipower rule, okay? So this is also called the antipower rule, because it really is the antipower rule. It's just been it's just been souped up a little bit by incorporating in the idea of the chain rule for differentiation. Okay. All right. Now, it's hard for me to write out the this enhanced version of the antipower rule. Write it out in symbols. So I've written it out in words for you. Okay. Here's the way the antipower rule works. If you have an expression, this can be any expression at all, all right? If you have an expression, so that can be a complicated expression, all right, raised to a power, okay, and this can be any power at all, all right, almost, okay, then also times the derivative of the expression, all right? So you must also have the derivative of the expression multiplied in, okay, see that, derivative of, I'm talking about this expression, then it's easy to integrate, okay, this is easy to integrate. It's just going to be the expression raised to the power plus 1 divided by our power plus 1. See, it looks like the anti-power rule, correct, right, okay? So how is this, how is this version of the anti-power rule different from the previous version that I showed you? Okay, so why am I saying, oh, this is better, or this is a souped-up version of the anti-power rule? See, in the simple version of the anti-power rule, what expression are you raising to a power? Just what? The x, right. You just have plain old x raised to a power. Okay? Right? Just plain old x raised to a power. In the enhanced version of the antipower rule, what this says is you don't really have to have just x raised to a power. You can have any expression raised to a power, okay? Any expression raised to a power. It doesn't have to be this simple just x, okay? It can be any expression raised to a power, but you must also have multiplied in what? The derivative of the expression, right, okay? You must have the derivative of the expression multiplied into your integrand, okay? All right, so if you have expression raised to a power times the derivative of the expression, okay, then that's going to be easy to integrate, okay, just in this fashion, right? So you just have the expression raised to the power plus 1 divided by power plus 1. Of course, don't forget to add on the constant there. Notice that when you take the antiderivative here, right, when you take this antiderivative, what happens to the derivative of the expression? It disappears. Notice that, right? Okay? It disappears. The derivative of the expression does not appear in your antiderivative. Okay? I always like to say, oh, it gets absorbed in the anti-differentiation process. All right? But it's important that you have it there to start with, okay? It must be there, or this rule does not apply, okay? Again, this rule has one exception, though. Your exponent cannot be minus 1. Your exponent cannot be minus 1, just like with the standard antipower rule. In this enhanced version of the antipower rule, the exponent cannot be minus 1, okay? So it has that limitation. Now, the enhanced version of the antipower rule is often not called the enhanced version of the antipower rule. This a technique for integration is often called integration by substitution. And I'm going to explain why it's called integration by substitution in just a second here, okay? And so that's what we'll refer to it as throughout the course, okay? We'll call this really integration by substitution. All right, okay, so, we're all primed here now for our next example where we're going to apply integration by substitution, okay, and we're going to find the antiderivative of this integrand. Wow, that looks way harder than x raised to a power, right, okay? So that's something way more complicated, right? You got these trig functions multiplied in here. That looks terrible, okay? But this is going to turn out to just be a piece of cake. To find the antiderivative, because we're going to see it fits so beautifully into the integration by substitution format, okay? And then I'll get a chance to explain why we call this integration by substitution. All right, but let's take a minute there. So we're going to come back and let's refresh ourselves first before we tackle this one. So we'll come back in 5 or 6 minutes. It's 1:59 now, and then we'll start with this integration by substitution. Yeah. When will I what now?
Start recording for the Flux.
Immediately.
So if I go tomorrow, I'm going to have $2.
Yeah, you can't go tomorrow because it's not open. When is your first session, though, Taylor? Oh, on Wednesday. So you can go Wednesday. The tutoring center is not open, I think, until Monday. The math center is not open until Monday, I think. It's not open until Monday. But Taylor's first session will be Wednesday. So you will get credit for that. Yeah, starting Wednesday. Yeah. Okay. All right, so let's take a few minutes there, and then we'll come back and tackle this one. Okay, let's resume. All right, so let's tackle this. All right, so to apply the antipower rule here, the way it's written, right? We've got to get the integrand into this format if we can, right? Okay, so and so sometimes that can be challenging. I think here, not the worst example, but sometimes trying to rewrite an integrand in this format is not easy to do, okay? So first thing is I don't want this coefficient here, right? Okay, because that's really not part of the way I've gotten the rule written here. So I'm going to extract that coefficient from in front of the integrand, right? So I have 3 times sine squared of x and then cosine of x, right? And now I need to have here an expression raised to a power, correct? Well, we do have a power in the integrand. We have this square, correct? So obviously that square is going to have to, somehow help me with writing an expression raised to a power. And here the expression that's being squared is sine of x, right? Sine of x is an expression, and we're squaring sine of x, right? So we do have at least part of what we need, right, for the anti-power rule. So let's make that a little bit more clear, though. I'm going to rewrite that sine squared of x as a sine of x squared. Those mean the same thing, right? And then times the cosine of x, okay? And see, now we're in maybe in really good shape, right? Because we have this expression. It's not just x, but it's sine of x, right? So we have this expression raised to a power. The power is not -1, it's 2, so that's good, okay? But now the other thing we need, however, for the anti-power rule to work is we need the derivative of the expression multiplied in. So that just has to kind of be a lucky break, right? That's really necessary for this integration by substitution to work. But you've got it here, right? Because what is the derivative of sine of x? It's cosine of x. Sure, right. Okay, so remember that from Calculus 1, right? So you see, you've got exactly the format that you want. You have an expression. In this case, it's sine of x raised to a number, right? Okay, not -1, in this case 2, right? And then you have the derivative of the expression multiplied in. So this is going to be really easy to integrate, right? Just according to the anti-power rule. So what does my anti-power rule say is the antiderivative here? Well, I left myself lots of room, right? Okay, so what's our antiderivative going to be? Keep the 3, right? That hasn't, we can't eliminate that. But we're going to have 3 times what? Sine of x cubed, right? Raise it to the 3rd power, divided by 3, right? Okay, and then you add in the constant. Isn't that what this says, right? You take the expression, sine of x, power plus 1, so that's 2 plus 1 is 3, divided by 3, right? Okay, and then we add in the constant. And again, see, this is nice, the 3's divide out, so I just get sine of x cubed plus constant. And normally you would write a sine of x cubed as sine cubed x, means the same thing, plus the constant. Oh, so there it is. There is the antiderivative, right? See, it was just that easy. What happened to the cosine of x? Nothing happened to it, okay? It's not going to appear, however, in your antiderivative, right? Okay? Not going to appear in the antiderivative. So it kind of, as I said there, it kind of gets absorbed in the integration process, okay? Let's check now to see if we have done this correct, all right? So one of the good things about integration is you can often check your work, not always, but, well, theoretically always you could check your work, but it's not always practically easy to check your work. But here, I think we can check, okay? So let's take the derivative of sine cubed of x plus a constant, right? And see if we don't get 3 sine squared of x cosine of x, right? Okay? Remember, here we're finding the antiderivative. This is the antiderivative of this. So when you take the derivative of sine cubed of x, you should get the what you started with, right? Okay? We're doing the opposite of differentiation. Well, let's check that. So let's find the derivative of sine cubed of x, right? Plus this constant. All right, so let's see. How do we differentiate now sine cubed of x? There you use the power rule, okay, right? So we use the anti-power rule to find the antiderivative. Now we're going to use the power rule to find the derivative, right? Okay, so you bring the 3 down, right? You're going to bring the 3 down and subtract 1 from it. So you're going to get 3 times sine squared of x. But here now is where the chain rule comes into play, all right? So remember, the chain rule for differentiation, right, says if you're differentiating an expression, not just x, but if you're differentiating an expression using one of your differentiation rules, so we're differentiating this expression using the power rule for differentiation, you have to remember, if the expression is not x, you must multiply in the derivative of the expression. So we have to multiply in here the derivative of sine of x, which of course is what? Cosine of x. So that's where the cosine of x comes from, right? Okay, it comes from the chain rule when you're taking the derivative of sine cubed of x, right? And of course the derivative of a constant is 0, right? Well, that is what we started with, correct? We were trying to integrate 3 sine squared x cosine x. We came up with this, and the derivative of this is 3 sine squared x cosine of x. So we have definitely got this question correct, right? We are certain that that is the right antiderivative. Okay, now, the tricky part, again, of using this enhanced version of the antipower rule is you have to recognize that you have an expression raised to a power, and then multiplied in is the derivative of the expression. That's not always so easy to see, however, okay? It's kind of very clear in this problem, because I made this problem kind of easy. But in general, that's not an easy thing to recognize, all right? So I want to show you a second way of solving this problem. We're still going to use the antipower rule, okay? But we're going to go through the steps a little bit different. And this a little bit different procedure that we're following here in the long run is going to be preferable, okay? All right? So in this problem, it may seem like it's unnecessarily clumsy or cumbersome, but in the long run, it's going to reap all kinds of benefits, all right? All right, so let me show you kind of the second way of attacking this problem. All right, here's what I'm going to do, okay? I am still going to rewrite the original integrand, right? By factoring out the 3, okay? Well, no, let's not even factor out the 3. That's not even really necessary, okay? So I'm not even going to go through the bother of factoring out the. I'm not even going to go through the bother of factoring out the 3, okay? But here's what I am going to do. I do want to remind myself that sine squared of x means sine of x raised to the second power, right? Okay, so I do need to remember that fact. All right, now, so see, that's an expression raised to a power. That is an expression raised to a power, and that reminds me of the antipower rule, okay, right? Okay, so I'm thinking, expression raised to a power, maybe I can integrate that using the antipower rule, okay? Maybe I'll be able to integrate that using the antipower rule. All right, so here's what I'm going to do, okay? I am going to substitute a new variable for sine of x. Here's you see where the terminology integration by substitution comes about, okay? So I'm going to substitute a new variable for sine of x. And you can choose any variable that you like to substitute for sine of x. But the traditional choice here is u, all right? So what I'm going to do here is we're going to let u be equal to sine of x, okay? Now, again, why did I make that choice? Because I was thinking, sine of x is an expression raised to a power. That was sort of the only thing I was noticing there, right? Because I had that expression, sine of x raised to a power, so I'm going to let u be sine of x, okay? All right, now, once we have made that choice that we're going to make that substitution, I have to rewrite the whole integral where it doesn't contain x. All right, so I cannot have any x's in the integral. I'm going to substitute this new variable u, and I don't want to have any x's left in my integrand. All right, so that requires a little bit of work, but it's a kind of a very straightforward process. All right, so let me show you what we do here. All right, first let's take the derivative of u. Let's take the derivative of u with respect to x. So I'm going to compute du dx, the derivative of u with respect to x, right? You were thinking of u here as being a function of x, so I want to take the derivative of u. What is the derivative of sine of x? Cosine of x, right. So du dx is cosine of x. All right? Now, the reason that I took that derivative is because I'm going to solve this equation for dx. So I'm going to treat the dx like a fraction, and I'm going to solve this equation for dx. All right? Going to solve that equation for dx. All right, so let's see, how do I do that? If you're going to solve that equation for dx, what would y'all do first? What? See, I want to write dx equals something. I want to solve that equation for, I want to get dx equals something here. What? Cosine of x over 1. All right, so don't try to outsmart yourself here. Just take it one step at a time. To isolate the dx, let's see, I need to get the dx out of the fraction, out of the denominator, right? How can I get it out of the denominator? Multiply both sides by what? Dx, right? Multiply both sides by dx, right? So I'm going to multiply both sides by dx here. So I get dx times du over dx is equal to cosine of x times dx, right? Okay. Here the dx's will divide out, so you get du is cosine x times dx. Now to solve for dx, just do what? Divide by cosine of x, right? So you get dx is what there? Du over cosine of x? Is that right? Right. Okay. All right, now, here's why that's important. Because now, in my integrand, I'm going to start substituting. What am I calling sine of x now? U, right. So, wherever I see sine of x, I'm going to put u, right? Okay, just u there. And now, what about dx? Well, I know what dx is also, right? It's du over cosine of x, correct? Right? Okay. So where I have dx, I can substitute du over cosine of x. Now, unfortunately, I don't have anything to substitute for cosine of x, but let's see what happens. All right. So let's see. I get here 3, and then what's the sign now? U squared, right? And then I have cosine of x, and then what's dx? It's du over what? Cosine of x. And see, we get lucky here, because what happens with the cosine of x? It cancels, right? Okay, so great break there. Cosine of x cancels out, and you end up with, let me write it down here now. So I'm going to erase this. So you end up with this integration problem. You just have 3u squared and then times du. And wow, that looks like, isn't that like the problem we just did right at the beginning of the, isn't that was the first example that we did? What was the first example that we did here? Yeah, it was 3x squared dx. What we have is almost the same thing, right? Except it's what? 3u squared du, right? Essentially the same problem, right? Except we have the variable u instead of the variable x. Big deal, right? Okay, so we know what the answer is going to be here, right? What did it turn out to be? U cubed, right? What? Plus that constant, correct? U cubed plus that constant. So I know what this is going to be. This is going to be u cubed plus the constant. Now, we're almost finished here, except we have to remember, when we started the problem, what was the variable? X, not u, right? So I have to undo my substitutions now because I have to get the variable x back again. But that's easy to do because what's u? Sine of x. So wherever I see u, I'm going to plug back in sine of x now, right? Okay? So we end up with, just very easily here, right? Sine of x cubed, right? Plus this constant. Of course, sine of x cubed is really sine cubed x plus the constant. There it is, right? Same answer, just went about a little bit different way, okay? All right, so now at this point you may not see the advantage to the second way, okay? But I claim in the long run that's the best way to go. So we're going to try to, for the most part, use that substitution method, okay? So we're going to try to force ourselves to do things by substitution, okay? Because we'll really reap benefits from that in the long run. Okay. All right, well. Let's see if we can try this one. Wow, okay. So that one looks horrible, doesn't it? So we want to see if we can find the antiderivative of x over, and then this expression, x squared plus 1 to the third power, right, but in the denominator, okay? But in the denominator. All right, so let's think about how we would think about this, okay? Look, the first thing I would do is I want to get rid of the denominator, okay? So I want to rewrite the x squared plus 1 to the third power that's in the denominator. And that's easy to do by changing that positive 3 to a negative 3, right? Isn't that what negative exponents mean after all, right? Okay? Don't negative exponents mean take the reciprocal, right? So x squared plus 1 to the minus 3 power is the same as 1 over x squared plus 1 to the third power. Now, of course, these expressions are the same, but the reason that I did this was I wanted to make this kind of look like an expression raised to a power, right? So I kind of wanted to make it look like I can maybe use the anti-power rule, or I could maybe use integration by substitution. And so that's what I have here now. I have an expression raised to a power, okay? And so now we have perfect opportunity for perhaps, but perhaps not, okay, for integration by substitution, all right? So that's what we want to try, okay? All right, so I'm going to let y'all try this, but before we do that, I want y'all to suggest to me what would be the correct substitution here. We're going to use u equals something, but what should we let u be equal to? Yeah, the base of this power, right? Okay, just like we did in the previous example. So let's let u be x squared plus 1, okay? Let's let u be x squared plus 1, right? So let's see if we can go through those same steps as before. Let me scroll up a little bit. Let's see if we can go through those same steps as before, right? Okay, except instead of having u be sine of x, we want, like we had before, right? We're going to have u be x squared plus 1, okay? Right? But we're going to carry out exactly the same process there, okay? Exactly the same process as before. And let's see if we can find what that antiderivative is, okay? Now, you should be rather impressed with yourself if you can do that, because that's not a simple expression to find the antiderivative of, okay? That's not at all trivial, all right? So if you can find that antiderivative, that's good. That means that means this technique is kind of powerful, right? Okay. All right, so I'm going to let y'all try that, okay? Try going through the substitution steps, and Taylor and I will help you with that, okay? All right. So on just some paper, and this is not a quiz by any means, so you can talk with whoever is around you, okay, all right, and ask them, am I doing this right? Or you can ask Taylor and me if we're doing this right, or you can ask us for hints, okay, as to how to go about doing this, all right? So I left the other one up there as a guide. See if that can help you. The steps are going to be the same steps. Of course, they'll look different, but they'll really be exactly the same steps, okay? Are you finding du dx there? Yeah. So what's du dx? That's pretty easy. No, don't let me make you nervous. Yeah. No, you're integrating, but this is differentiating. Right? Yeah. Remember, when you find du dx, you're differentiating. So be careful about the difference between integration and differentiation, right? Okay. The differentiation is all right. So that's right. So what is dx then? Because you want to solve for dx. So you're right. Du is 2x times dx. Then what's just dx? How do you solve for dx?
Divide by 2.
And you have to divide by 2 and what?
Divide by 2 and...
Yeah, you got to get dx, right? Dx by itself. So this you got to get rid of this. So you're dividing by the 2, but you also have to divide by what?
X.
Yeah, right. Both of them, right? Yeah, okay, right. You got to get rid of both of those things. Did you, right. So what is dx? Du over what?
Yeah, so you have to...
Over this? No, over just 2x.
Over what?
Over 2x?
Yeah, there it is. Yeah, so dx is du over 2x. Right, yeah, okay. And now you're in business, right? Because this is going to become u, right?
Right.
And this is going to become dx, right? Okay? All right. And now see what happens. Some things are going to reduce there. Is it Janaya? Am I getting the name right? Oh,
Yes, that's right.
Good. All right. Okay. All right. So now did you do your substitution? Is that what you're doing now?
Yeah.
Okay. All right. Yeah. This is right though. So that's the correct thing. All right. So far so good, right? Okay. Yeah. All right. Oh, y'all are doing great here. So perfect. Now what's going to happen here? Don't forget your antiderivative though. Right. So what's going to happen now?
Somehow they factored out a 1/2. I'm not sure how that's...
Yeah, so, but before that even, what good thing happens here? This x and this x cancel. And that's really necessary, right? Okay, now you've got this over 2, that's a 1/2. So what can you do with that 1/2?
Factor it out.
Factor it out. It's like factoring out that 3 in this example, right? So you have 1/2 and then what? U to the minus 3 du. Yeah, now you can integrate that though, right? Because how do you integrate that?
I get nervous under pressure.
Okay, you're not under any pressure. Yeah, I'm not gonna slap you or something. So it's u to the.
Is it plus 1?
Yeah, right. Exactly. Yeah. All right. This is good, right? So you can simplify that a little bit. You can multiply these in here, right? Okay. But that's it. Yeah. Nice. I forgot your name. What is your name?
Yeah.
Yeah. Okay. All right. So. Yes.
You see my answers right?
Sure.
I got that.
I think it's correct, but there's a minus sign somewhere, right?
Yeah. Oh, so it's going to be negative right here.
Yeah, it's going to be negative, right? Yeah, right, yeah, okay. Yeah,
good?
but that's good. Yeah, that is good. All right, so you're making progress there. Now you're ready to substitute, right? Because you've got what dx is equal to, so now you can substitute for this, and you can substitute for dx, okay? And then things will get kind of clear there. Did you finish it?
I got the dx and the u.
All right, so now you want to substitute, right? So what is this? That is u, right? So put u here, and then where you have the dx, put this. Okay, and then see what happens when you do that. All right.
Add 1 and then divide. So what's going to change here?
I'll let Taylor tell you that. What'd you get?
That. Well, I initially got this, but to
This is
get rid
correct.
of the negative.
Yeah, but this is not going to go up. This is
Okay.
going to stay down. So you're going to end up with minus 1/4
Okay.
this. Yeah.
Gotcha.
Right. Yes. wait. I'll be right there. So get it? Yeah, so that is what dx is, right? So now you're ready to substitute, right?
Okay.
So you have x, all of this is u,
Mhm.
so you have u to the minus 3, right? And then the dx is going to be du over 2x, right? Now, this will simplify a little bit, right? Because what's going to happen to the x's? Yay! No, not the 2's.
We'll have 1x.
No, the x will go. This x will
Both of
cancel
them?
this x. Yeah,
So
those
it
x's will
wouldn't be-
cancel.
It wouldn't be this?
No.
It
It's
would
the
just be
yeah,
du?
it's no, it will be this. This x cancels and this x cancels.
Oh, my 2 is
But the
left
2's
behind.
stay,
Oh,
yeah.
because it's not x times
Yeah,
x.
right.
It's 2. Okay,
Yeah,
I
right.
forgot about that.
Now, but this you can factor out because that's a number, so you can factor that out in front. It's like factoring the 3 out when we did up here.
Oh, yeah.
But what are you factoring out?
The 2.
Yeah, but it's in the bottom, so you're really factoring out what?
1/2.
1/2, right. You're factoring out 1/2. Yeah, okay. All right.
Is this close to the right answer?
Really close, but something is missing. So what did where did that 2 go to?
I put it came up here since the x cancels out since it's a constant.
Yeah, the x cancels out, but that doesn't go up.
It doesn't go up, so it stays on the bottom?
Yeah, so it stays on the bottom. So what do you have out here?
1/2.
1/2, right. Yeah, 1/2. Yeah, right. Okay, is that what you got?
No.
Okay, all right. All right, okay. All right, so fix that. I think that's right. Yeah, I think that is correct. Good. Yeah. Did you get the same thing? Okay. All right. All right. Did you? All right. You're in great. You're in good shape now. Because what's going to happen to these x's?
I guess that's 1/2 because that's not 2, so they won't cancel.
No, the x's will cancel, right?
Well, the x's won't
Yeah.
cancel.
Oh, I see. Yeah. So the x's cancel. Now that is 1/2. You're right. So we can pull that out in front as 1/2, just like we pulled the 3 out here. You can pull out a 1/2, right? And then you'll be in really good shape when you write it down like that.
I don't know what I'll do.
Okay, let's see if we can. So most people got pretty far into this. If you didn't get all the way finished, you can watch me finish it because you're just right. You'll be right just on the cusp of finishing it, right? So we had already decided that we were going to let u be x squared plus 1. That was going to be our basic substitution there. So once you've chosen that, you have to compute du dx, though. So you have to take the derivative of, you're not integrating here, you have to take the derivative of x squared plus 1, which turns out to be 2x, according to the power rule, right? You bring the 2 down, right, okay? And then the derivative of 1 is 0. So you get du over dx is 2x. Which if you solve that for dx, you will get, I'm skipping the steps here, but if you solve that for dx, you will get dx is du over 2x, okay? And then that now is what you're going to substitute for dx here, and then for x squared plus 1, right, you're going to substitute in u, because we're letting u be x squared plus 1. So let's see what happens there. We would get antiderivative of x and then u to the minus 3 power, And then dx now is du over 2x. And now we're praying here that something good happens, because remember, we want to have the integrand that involving just u but no x's. And so we're not, at first, it's not clear that's what's going to happen. But now we see that it does, right? Because these two x's will cancel, correct? Those two x's will cancel. And so all the x's are gone. So we're in really great shape. Now, the 1 over 2 here, this 2 is still in the denominator. That's just a constant. So we can factor that in front as 1/2. Just like we factored the 3 out in this earlier problem, you can factor this 1/2 out in front. So you have 1/2 u, antiderivative of u to the minus 3 du. And now that's just a simple application of the antipower rule to find this antiderivative. That's going to be u to the minus 2 power, add 1 to the exponent, and then divide by the new exponent, which is minus 2, right? And then don't forget the constant that you're adding on. And then you can simplify this a little bit. You can multiply in the 1/2 here, right? So you would get u to the minus 2 over minus 4. 2 times minus 2 is minus 4, right? Plus the constant. And if you don't like negative exponents, you could write that u to the minus 2 as 1 over u squared, right? You can pull the u to the minus 2 to this denominator. So you would end up with 1 over minus 4 u to the positive 2 plus a constant, okay? Right? When you bring u to the minus 2 from the top to the bottom, the sign of the exponent changes. You still have minus 1/4 here, though, okay? And then plus the constant. So there it is. There is the sort of the answer. We have one more step, though, that we have to do here, right? I have to unsubstitute. So remember, u was, I forgot, x squared plus 1, right? So I get, finally here, 1 over minus 4 times x squared plus 1, because that's what u is equal to, squared, and then plus the constant. Oh, nice, right? So there were several steps there in finding that antiderivative, but none of them were terrible, right? Okay, they were all fairly straightforward. But that's really a very complicated expression to find an antiderivative for. So, so that's kind of impressive that we could find that antiderivative. All right, so actually a lot of machinery goes into finding that antiderivative, right? It's the antipower rule and also the chain rule, right? Which is a very powerful tool in Calculus 1, okay? So there really is a lot of mathematics wrapped up in that example that allow us to find the antiderivative of that pretty complicated integrand there. All right, now, the problem with the antipower rule, all right, so, well, we've got a few examples under our belt here of using the antipower rule or integration by substitution. But the problem with the antipower rule is it doesn't work when you're the exponent of your expression, the power on your expression is minus 1, right? That's the great limitation. So what that means is that some fairly simple antiderivatives we cannot compute, all right? In particular, we don't know what the antiderivative of 1 over x is. That is such a simple expression, 1 over x. We should be able to write down its antiderivative, but we cannot, okay? We don't know what the antiderivative of 1 over x is. Now, what's the problem here? Well, if you write 1 over x with a negative exponent, you get x to the minus 1 power, right? So the antiderivative of 1 over x is the antiderivative of x to the minus 1 power, and you cannot use the antipower rule there, okay? Because the exponent is minus 1, okay? So very simple integrand, 1 over x, but we don't know what its antiderivative is yet because the antipower rule won't help us here, right? Here's a little bit more complicated one, but again, the antipower rule is going to fail us here. The reason is, if I rewrite this denominator using a negative exponent, I get 2x times x squared plus 3 to the minus 1 power. And that is an expression raised to a power. So you see, we would think, oh, the antipower rule is going to help me find this antiderivative. But unfortunately, because the power is -1, the antipower rule won't apply, right? So can't find, we don't know yet how to find the antiderivative of this expression either. That one looks even easier than this one. So, so why can we find the antiderivative here, but we cannot find the antiderivative of this, right? Okay. That looks like a simple, or almost exactly very similar problem, right? This one and this one, but this one we could solve. This one right now we're stuck. All right, so that's where we're at, right? How are we going to find antiderivatives of expressions like this one, where the antipower rule is not going to apply because the power is -1? All right, that now is really the beginning of the course. That is really the first new thing we're going to learn in this class. These examples are really left over from Calculus 1. You may not recall them very well from Calculus 1, but they were in Calculus 1. But this is new, all right, okay? So that's the problem that we have to take up next time. What is the antiderivative of 1 over x? It can't be that hard, right? Okay, what is it? All right. Okay, so I'm going to see y'all on Wednesday, right? Get registered on, get enrolled, I should say, in WebAssign. You don't have to register. That's when you pay, is when you register. Again, you don't have to pay yet, but you can get enrolled just with the class key, okay? All right.
Are you taking attendance today?
Not today, no. Possibly next time or maybe next Wednesday.